Immortality, the dream of living forever, has captured human imagination for centuries. From ancient myths to modern science, the pursuit of eternal life has evolved dramatically. But what does science say about immortality? Can we really escape the inevitable fate that awaits us all? Join me today as we explore the cutting-edge science that's pushing the boundaries of human lifespan. We'll delve into the cellular and genetic mechanisms of aging, explore futuristic technologies like cryonics and mind uploading, and grapple with the profound ethical implications of extending life indefinitely. Fasten your seatbelts, folks, because we're about to embark on a mind-blowing journey into the future of humanity, a future where death itself might become optional. At the heart of the quest for immortality lies a fundamental question. Why do we age in the first place? Aging is a complex biological process driven by intricate cellular mechanisms. Imagine your cells as tiny machines, constantly dividing and replicating. Over time, these machines wear down and accumulate damage. That's aging in a nutshell. Telomeres, the protective caps on DNA, shorten with each cell division. Eventually, they become too short, leading to cellular aging. Scientists are exploring ways to slow or reverse this process. The dream of immortality might not be so far-fetched after all. Now, if we're talking about manipulating the very building blocks of life, we have to talk about the revolutionary field of genetic engineering. Imagine having the ability to edit our DNA like a piece of text, snipping out the bad parts that cause disease and aging, and maybe even inserting some bonus features for good measure. That's the incredible power of technologies like CRISPR-Cas9. CRISPR has taken the scientific world by storm, and for good reason. It's like having a pair of molecular scissors that can precisely target and cut specific genes within our DNA. This groundbreaking technology has the potential to revolutionize medicine, allowing us to treat genetic diseases at their root cause. But CRISPR's potential goes far beyond just curing diseases. Scientists believe that by using CRISPR to manipulate genes associated with aging, we might be able to slow down or even reverse the aging process itself. Imagine a future where we could use gene editing to enhance our DNA repair mechanisms, boost our immune systems, and protect ourselves against age-related diseases. Of course, with great power comes great responsibility, and the ethical implications of tinkering with our genetic code are profound. Should we be editing the human germline, making changes that would be passed down to future generations? What are the potential unintended consequences of such powerful technology? These are questions that society must grapple with as we venture further into the uncharted territory of genetic engineering. The ability to edit our DNA has the potential to reshape the future of humanity and perhaps even redefine the limits of our lifespan. Some scientists believe that instead of just editing existing genes, we might one day be able to create entirely new genetic blueprints for immortality. Imagine designing organisms with built-in mechanisms for indefinite lifespan, or even engineering human cells that can regenerate and repair themselves indefinitely. This might sound like pure science fiction, but researchers are already making progress in understanding the genetic basis of extreme longevity in certain species. Now, let's shift gears for a moment and talk about another exciting frontier in the pursuit of longer lifespans: biotechnology. Imagine a future where we can repair or replace our failing organs with brand new ones, grown in a lab or even 3D printed on demand. It might sound like science fiction, but the reality is closer than you might think. Scientists are already making incredible strides in the field of regenerative medicine, developing innovative techniques to grow tissues and organs in the lab. One promising approach is using stem cells, those remarkable cells that have the potential to develop into any type of cell in the body. Imagine taking a small sample of your own cells and using them to grow a brand new heart, liver, or even a new brain. This isn't just science fiction, folks. It's an area of active research with the potential to revolutionize healthcare as we know it. And if growing organs in a lab isn't mind-blowing enough, how about 3D bioprinting? Imagine a future where we can literally print out functional organs on demand using biocompatible materials and living cells as ink. This technology is still in its early stages, but the possibilities are truly astounding. Think about it. No more waiting lists for organ transplants, no more worries about organ rejection. If a vital organ starts to fail, we could simply print out a new one, perfectly matched to your body. It's like having a biological spare parts store right at our fingertips. Scientists are also exploring ways to use these technologies to repair damaged tissues, and even reverse the effects of aging at the cellular level. Imagine using nanobots, tiny robots smaller than the width of a human hair, to deliver drugs, repair damaged cells, and clear out the cellular debris that accumulates with age. Now let's dive into a topic that's a bit more, shall we say, out there. Cryonics, the practice of preserving human bodies at extremely low temperatures after death, has long captured the imagination of science fiction writers and futurists alike. But could this seemingly far-fetched idea actually hold the key to cheating death, at least temporarily? The basic premise of cryonics is this: by freezing the body at ultra-low temperatures, typically minus 196 degrees Celsius, all biological activity, including the processes of decay, grinds to a halt. The hope is that by preserving the body in this frozen state, we can buy time until medical technology advances enough to repair the damage caused by both the freezing process itself and whatever ailment caused the person's death in the first place. Now, I know what you're thinking. Neil, isn't this just wishful thinking? Once someone is dead, aren't they? Well, dead, and you'd be right, at least according to our current understanding of death. But here's where things get interesting. The definition of death has become increasingly complex as medical technology advances. In the past, death was often declared simply based on the absence of a heartbeat and breathing. But we now have technologies like CPR and defibrillators that can restart a heart that has stopped beating, and ventilators that can breathe for us if our lungs fail. So the line between life and death isn't always as clear-cut as we might think. Proponents of cryonics argue that by freezing the body shortly after death, we can preserve the intricate structures of the brain, including the connections between neurons which encode our memories, personalities, and everything that makes us unique. The idea is that if we can preserve this information, then perhaps one day, far in the future, advanced technology could be used to revive the individual, effectively bringing them back to life. Now, let's venture even further into the realm of speculative science and explore the mind-blowing concept of mind uploading. Imagine a future where we could transfer our consciousness, our thoughts, memories, emotions, and everything that makes us us into a computer or a synthetic body, essentially achieving a form of digital immortality. The idea of uploading our minds might seem like pure science fiction, but it's based on a fundamental assumption about the nature of consciousness, that it's not some mystical or supernatural phenomenon, but rather an emergent property of the brain, a product of billions of neurons firing in complex patterns. If consciousness is indeed a product of information processing in the brain, then theoretically it should be possible to replicate that information processing in a different substrate, like a sufficiently advanced computer simulation. This simulated environment could be designed to perfectly mimic the real world, or even create entirely new virtual worlds for our uploaded minds to inhabit. Now I know what you're thinking. Neil, even if we could create a perfect simulation of my brain, wouldn't it just be a copy of me, not the real me? And that's a question that philosophers and scientists are still grappling with. What does it mean for something to be conscious? And is there a fundamental difference between a biological brain and a sufficiently advanced artificial one? These are deep questions, folks, and we don't have all the answers yet, but the idea of mind uploading raises some fascinating possibilities. Imagine a future where we could explore the universe at the speed of light, unconstrained by the limitations of our physical bodies. Imagine being able to communicate with other minds across vast distances instantaneously, sharing thoughts and experiences in ways we can only dream of today. But along with these exciting possibilities come profound ethical and philosophical challenges. While immortality raises exciting possibilities, it also poses profound ethical and philosophical questions. How would society function if people lived forever? Would resources be sufficient? And does eternal life diminish the value of living? The science of immortality is a journey at the intersection of biology, technology, and philosophy. Will we ever unlock the secret to living forever? Or is death an essential part of the human experience? The quest continues.